This is lesson 4-5, and it is about factoring expressions. It will start in your workbook on page 222. Let's start with example 1 on page 222. It says Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each of which covered X square meters, and a different size can that covered 12 square meters. What are possible length and height dimensions of Kiana's mural? So let's start off just thinking about what kind of an expression we could write for this. So for example, she used 3 cans, each one covered X square meters, and is addition 12 more square meters of a different sized can. So we're going to start with this expression. 3 full cans that are X meters plus an additional 12 meters. So here you see that they have a visual representation of the expression that we just came up with. We had 3x plus 12, and if you look, they have a rectangular model, and right here, these are the 3 cans of paint, and this is the extra, and we are going to add them together. So one way to figure this out is to figure out what number goes into both 3 and 12 so that we can get our left-hand side. Okay, now, I used to teach elementary school, so when we were finding GCF, greatest common factor, and I was in the elementary school, those kids like bugs. We used bugs to help us figure this out. So we drew ourselves some cute little bugs. This is the 3 bug, and this is the 12 bug. And we thought about all the numbers that I can multiply together to get 3 or 12, and those became the legs on the bug. So on the 3 bug, I can take 1 times 3, but that's it. On the 12 bug, I'm going to make the 12 bug a different color. On the 12 bug, 1 times 12 works, but so does 2 times 6, and so does 3 times 4. So if I look at that and I look at the legs of the bug, I'm looking for the biggest number that I can find that's in common between the two. And if I look, I notice there's a 3 in both of those. So over here, we happen to have another way. And that's to use the greatest common factor to help us use the distributive property backwards. So if I have my expression, let me change that into a pen and not a highlighter. If I have my expression 3x plus 12, and I pull out the biggest common factor, that leg on both bugs, I pull out a 3, that's going to leave something plus something in the middle. So if I pull out a 3 out of 3x, that leaves just the x. If I pull a factor of 3 out of 12, well, 3 times 4 is 12, and I've just done backwards distributive property. That is called factoring expressions. Now, don't get worried if you didn't catch that the first time. We're going to go over it several times. All right, this is the example number 1. Try it on page 222. And I know that I have this expression and I want to factor it. I want to do backwards distributive property. So I'm going to go back to my elementary days. I'm going to have a 4 bug and I'm going to have a 20 bug. Now, if you're wondering where I just got those, I got the 20 bug right there, and I got the 4 bug right there. Now, I'm thinking of numbers that I can multiply together to get 4. Those are going to become the legs. So 1 times 4, 2 times 2, and that's it. When I do the 20 bug, I'm going to have more legs. I'm going to have 1 times 20, 2 times 10, and 4 times 5. And then I'm going to compare the legs. What's the biggest leg number on both bugs? So if I look, there's a 4 here and a 4 here. That is the biggest number in common. So that's going to come out here. Then I'm going to look. I need 4x, and I've got the 4. I was missing the x, and they put it right there. I need 20, and I've already pulled out a factor of 4. The other leg on the 20 bug that goes with the 4 is a 5. It's right here. They're paired up. If I've got the 4, I also need the 5. So what's going to happen is that we have a pool that is 4 by x plus 5. Oh, I guess I was supposed to put that in here, x plus 5. Again, I just want you to calmly think about this. We're going to do it lots of times. So if it is not making sense, that's okay. Let's keep at it. All right, we are at the top of page 222 with example number 2. Now, if you have a negative coefficient, there's actually 2 ways of doing this. So I'm going to draw out my bugs. I'm going to have a 2 bug, a 2, and I'm going to have a 6 bug. I'm not going to worry about the negatives quite yet. All right, on my 2 bug, 1 times 2, that's it. But on my 6 bug, I'm going to have a 1 times 6. I'm going to have a 2 times 3. And now I'm going to look and see what's the biggest leg common to both bugs. I've got a 2 on that bug and a 2 on that bug. All right. So if I happen to have the expression negative 2x minus 6, and I pull out a 2, how am I going to turn that 2 into a negative 2x? Well, I'm missing the negative, and I'm missing the x. Bring down my subtraction sign. Now I'm at the 6. Looking at my 6 bug, if I've already got the 2, I am missing the other leg that goes with it. I'm missing a 3. All right, that's one option. Here's the second option. What if, instead of pulling out a positive 2, I pull out a negative 2? Well, on my first one, if I have negative 2x and I pulled out the negative 2, that just leaves an x. On the minus 6, remember, negatives and subtraction signs are interchangeable, so I already have the negative taken care of out here with my negative 2. I can just make it a positive 3. That gets tricky, I'm not going to lie. But you can absolutely go from here and you can check your work. All right, here's the try it on page 223. All right, let's get some bugs going. I have to have a 4 bug. 4 would be 1 times 4 and 2 times 2. I need a 28 bug. 28. 1 times 28. 2, I know it's even, and 14. 3 doesn't work. 4 goes in 7 times. 5 doesn't work. 6 doesn't work. Okay, I'm done. So I'm going to look at my two bugs and find the biggest leg in common. 4. All right, there's two ways of pulling this out. I can pull out a positive 4. Remember, my expression was negative 4x minus 28. If I pull out a negative 4 and if I pull out a positive 4 and I need it to be negative 4x, I am missing the negative and the x. Use my subtraction sign. On the 28 bug, one of the legs is 4 and the other one was 7. That is one answer. But let me give you a different option. What if I pull out a negative 4? Well, if I pull out negative 4 and I had negative 4x, the only thing I'm missing is the x. The subtraction sign is taken care of with the negative. And if I pull a negative 4 out of 28, I am left with a 7. The 4 and the 7 go together. All right, so we actually have two options here. If I pulled out a 4, I'd have negative x minus 7. If I pulled out a negative 4, I would have an x plus 7. All right, this is example 3 on page 223. If you'll notice, they did their bugs. They just didn't do them cute. So here are the factors of 6. Those are the legs on the 6 bug. These are the legs on the 18 bug. These are the legs on the 12 bug. And they looked for the greatest common factor, the biggest number on all 3. So having done that, they pulled it out. They pulled out the 6. If we started with 6x and I pulled out the x, I'm missing the x. Minus. If I need 18 and I took a factor of 6 out of it, 6 times 3 is 18. Minus. If I need 12 y's and I took a factor of 6 out, 6 times 2 is 12, and don't forget your y. There you go. This is your try it on the bottom of page 223. And we are going to use the exact same expression. We had 6x minus 18 minus 12y. But this time they want me to pull out a negative. So instead of pulling a positive 6, I'm going to pull a negative 6. All right, now this gets tricky because negatives are always a little tricky. I pulled negative 6 out of 6x. So I'm asking myself, what can I multiply by negative 6 to get positive 6? And I have to go back to my integer unit. 2 negatives make a positive. Don't forget your x. Then I already have my subtraction sign taken care of. It's right there. 6 times what is 18? I already have my subtraction sign. It's right there. 6 times 2 is 12, and don't forget your y. All right, so this lesson is about pulling the GCF out and factoring expressions. You can absolutely use a visual model like they have on the left, or you can use the GCF with the bugs like we did on the right.